Hello, this is Clint Halstead, and I'm going to do a video on a step-up converter using Eagle CAD. So you should have two files for this project. You should have the datasheet.pdf and the step-up converter.schematic. I'm going to first open the datasheet, double-click that. This is the datasheet. If you go to page 5, then this is the schematic that we want to capture in Eagle CAD. We have some capacitors, resistors, an inductor, and a Schottky diode. And we have this MC340663 IC 4-pin package DIP, dual inline package, this package right here. Of course, it also comes in a surface mount package, but for now we're just going to use the DIP package, dual inline DIP, plastic dual inline DIP. Okay, so we're going to move this out of the way, put it on another screen if you have another screen, or you can put it beside it or print it off. And then we're going to go ahead and open up the schematic by double clicking on that. Wait a few minutes for that to pop up. That has popped up here. Now, if it won't open that way, sometimes the file association is incorrect. So another way to open it, if it doesn't open up properly, you can say open with, and then you may not have Eagle CAD here, so you can say choose default program, and you can click here, and the Eagle CAD should be under here. If you click that and say click always use the selected program, then that would work as well. But for me, I've already got that selected, so I'm just going to go ahead and open it. Now what should come up is a schematic window and a control panel window. You can just move this control panel window over to the side or something out of your way, and this is what you should have. Okay. So we're going to compare this to the schematic that we have here. And we're just going to start drawing. Now notice that I have pin 1 on the very right, 2, 3, 4, 5, 6, 7, 8. So the first thing I want to do is I want to reorient this package. So I want to just right click on that, the little X, right click on it and say move. Scroll out with your mouse to zoom in and out. And I'm going to flip this thing around, mirror image it, 1, 2, 3, 4, 5, 6, 7, 8. So click that little button up there and that should mirror image that. Now I'm going to move some of this out of the way so that I can make it look like the picture on the screen on the data sheet. Okay, so for the data sheet, the first thing I have is pin 1 going to this Schottky diode and then coming down here. So I'll draw this pin 1 and this first. So I'm going to take the diode, I'm going to right click on it and say move, and then if I click the right button twice, then it'll rotate around. I'll select that, then I'll select wire. You can turn on your grid if you want. And if you want to do dots or lines, then that's fine as well. I think I'll do dots. Hopefully you can see that. But so now I'll go ahead and click. I got the wire button selected here, so I'm going to wire from pin 1 to that terminal, and then I can click again to disconnect. Now this is called the anode and the cathode. The anode is the pin that the current enters into, and this arrow points in the direction that the current goes, so anode is always the direction that the current enters into the device. And then the cathode, we'll select the cathode, we'll come over here and we'll end it right there because you can see here that we're going to go to this resistor R2, which is 47 ohms. So we can get this resistor and move it, rotate it, select it there. Now what we can do is hit the the name tool. Well, that's already called name is R2, so that's correct, but we want to change the value to 47K. So we'll change this to 47. And we want to continue that connection to pin 5. So we'll just select the wire tool and we will continue that to pin 5. There we go. Now what we want to do is we want to add this capacitor here. So we will move that capacitor and we'll put it about right there. We will move this ground here. We can wire that up, double click, single click, double click. We need to put a dot here because that's more than 3 or more connections. So anytime you have 3 or more connections and you have a connection, you want it to be connected, then you put a little connection point. Okay, we also need to change this value. Notice that the capacitor is 330. That's going to be microfarads. So we'll put 330 there. So we hit the value tool. Yeah. So 330. It doesn't really say on the schematic, but it's actually microfarads, which would be lowercase u and then uppercase F. And on the schematic, we have that C0 or C out, but we could call it maybe C0. So we'll hit name. I don't know if it's going to accept C out, CO, but I know it's going to accept C0. Okay, so we have the capacitor. Now we want to have R1 here, 2.2K. So we can just right click this and copy, right click again, rotate it, left click to select it in. We can move this ground over. I always like to keep a little space there. Go ahead and select left click once, double click, left click once, double left click. Now we have 3 connections again. We don't need to add dots down here because it's only 2 connections, but if we have 3 or more, we add a dot. Okay, so it's called a junction officially. Now at this point we have a little bit of a schematic, so we can call this, we can rename this maybe, file save as, I'll just call it wired. The original one was not wired and this one will be wired up. 05 step up converter wired. Okay, so there we go, we're doing pretty good. That's R1 and that needs to be 2.2K. 2.2K. Now we want to create a terminal point on the output. Actually, if you look at this, look at the package, you can see that it looks like that. So it's just a little header pin that has 2 terminals on it. One of these belongs on one side and the other one belongs on the other side, and we can show you later how to determine that. But for now, we'll just randomly put it here. Notice that we have a V out here, so we'll make this terminal V out. We'll make this one ground. Over here it doesn't really show the terminal, but you know you have to have a connection point for ground when you go to wire things up. So we'll go ahead and wire that up. Left click once, double click. I'm actually going to move this ground down a little bit and move this point back up, or maybe delete it. Because I don't want, I want to make sure that I specifically have a good connection there. I don't like to put my connections on the part symbols. It can cause some issues when you go to look at it later. Okay, So the best policy always have the, don't have the junction point on the red part of the symbol. So let's continue on here, and what we're going to look at is the next thing we want to wire up is we'll do this path from pin 1 through the inductor to pin 8 through this resistor 180. So we will go ahead and grab the resistor, right click and say move, rotate it. Now notice that this symbol for an inductor is the European symbol. European symbol is a it's just a square, it's a rectangle that's filled in. For European symbols, they have a rectangle that's empty in the middle is for a resistor, and a filled in one is for an inductor. And if you have a line there, it just means that there's like a steel or a ferrite inside of it. So this is the American symbol. So you'll see either American or European symbols, and it's okay to have either one of those. Okay, so we want to make the value on this one, we want to make it 170 microhenries, and L1 is fine because there's only one inductor. Go ahead and wire it up to here, double click, enter a junction, and go ahead and wire this one to over here. Leave room for our other resistor. Let's put that 180 ohm resistor, so we can just copy one of these, place it there, wire it up, double click. We don't need a dot there because there's only two connections, so we don't need a dot. Go ahead and hit value, and that's 180 ohms. There's actually no name on it. If you notice, there is no R1, 2, or 3, so we can just leave it whatever we want. And there we go. That's wired up. Now let's continue to go on. Next thing, we can put a wire from here to 7. Let's go ahead and do that. So we're going to go ahead and click here, click pin 7, double click, and that connection should be made. We do need a dot here because there's three connections right there. So we'll put a junction there. I guess another thing you could do is move this out, because I don't want that, if it's over here, the wire's crossing that name. I don't really like that. So remember, you're going to print this out and let someone read it, so they don't really want to see that kind of stuff. So let's try to make it look neat. So again, there's 3 points right here, so let's put a junction. This does not need a junction, this does not need a junction. These are just 2 connections. So that's it. Go ahead and hit save in case you lose power. If you lose power without saving it, then you lose everything. So just make sure you hit save periodically. Alright, next thing is we want to go from pin 7 through RSCH 0.22 to 6. So we will copy a resistor, and we'll put it about here, and we will wire it up. It's a little bit more cramped than in the original drawing. R5 is fine because you could try to call it RSC, but I don't know if that would work. I guess you could try it, but I'm not sure that it would work, so I'm just going to leave it R5. Okay, and then the value is 0.22 ohms. So it's a very small value resistor. I don't know if I'll be able to find a 0.22. I may just be able to find a 1 ohm. I think that'll probably work good enough. But next we need a capacitor. So we can copy this one If you look here, there's a capacitor that goes to pin 6, and then there's the VN. So we'll copy this capacitor. We'll just say copy. Place it there. We'll put that right there. We will copy one of these grounds over. We'll place that as well. Actually, I'm going to move this down. I don't really like to have my connections like that. Yeah, you can't really move that junction, so I'm just going to have to delete it. Okay, let's move it over here. Doesn't really matter what name you choose. Okay, so now we'll put a junction. This is 3 or more, so we'll put a junction there. This is only 2. That's 2. That's 2, 2, 2. There's 3 connections there, so I'll put a junction there. And save it. I think it looks pretty good. We compare it to that. Only other thing I see, of course, we have these extra components here, so we can delete these. We don't need those. I'm actually not going to use this USB. This was for another part. You have to find the little crosshair. Sometimes it's hard to find, but it's right there. And then delete these components. Check it against your. Just look at it, compare it to the data sheet really close. Check every component. Well, it looks like I have 3 pins over here not connected to anything, so I got to fix that. Notice here that I have a 2 is connected to ground, so I'm going to zoom in on here. I'll copy this ground and I'll put that over here. Again, I try not to ever cross anything. Pin 3 goes to a capacitor, so I'll copy this capacitor. I'll put it over here. It's 1500 picofarad. So I will rename that picofarad. Wire that up. Let's see, I may need to move this. I need to move that ground over a little bit. Okay. So I have to try to get up through here. Okay. And copy this ground. Wire that up. Notice that I don't want this to be connected. So I'm not going to put a connection dot there. Since I didn't select on it, it's not going to be connected. If you want to prove that, you can move it and you can see it's not connected to the other net. So no connection here. And the only other point is number 4 here goes to ground, so we can copy this ground and we can wire that to this ground. Or you could have just wired it directly to that ground. That would have been really the same thing. But now the only other thing I see that really probably should be done is you can label some things. You could call this over here V out. Actually, if I put name, that's called X3, so I can call it V out. So now it's called V out. Now I can copy this. Copy. Actually, I'm just going to mirror it and then put it over here. This is going to be my VN. If you see here, this is a 12 volt VN. So we'll move one of these. Move this one. Okay. So let's wire this puppy up. Wire this one up. Move it up here. Wire that up. Put the connection dot on 3 or more points. Hit save. And There we have the VN. Oh, we need to rename that. So let's hit name. We'll click that and then we'll call it VN. There we go. Hit save. I think we're pretty good here. Just look it over really quick. Make sure you don't have any missing connections. We have V out. We have V in. Let's look at that package there. That's what the package looks like. It's just a couple of drill hole points so you can put a wire. That's all we really need. Make a point. That's not a connection. So just look it over really good. Make sure that you've got all your connections. Make sure you don't have any green wires going inside of your components or shorting any of your components out. And then you can be done. And then I'll show you how to do the PCB on the next video. Thanks. Before I move on to the PCB video though, I do want to mention how do we do a electrical rules check. So let's check the schematic, and if we go to Tools and go to ERC, or you can click this button down here, Electrical Rules Check. So ERC give you a list of errors. You can expand this out. You can click on each one of those errors. You don't have any. There's 0 errors and 2 warnings. It says VN has no value. You can say centered there if you want. It'll center it. VN has no value. Well, that's okay. Vout has no value. Well, that's okay. I want to approve that one and approve that one. Now let's say that we had an error. Let's say that maybe we deleted this wire and we saved it, and let's run the rules check and see if it'll catch it. We would hope that it would catch it. Okay, well that's good. It says disconnected pin D1C. So you can see electrical rules check can really help you catch errors. So please go ahead and we're going to just what you could say is if you close that, then just wire that back up and then save it, and then we can rerun that electrical rules check. And it says down here 2 approved errors, so there's no warnings, there's no box that came up that time. That's because there was no errors and no warnings. If there's no errors and no warnings, then the box does not come up, and it just gives you a message down here. 2 of those were approved, and once you approve them, you don't have to, it won't flag those anymore if you approve those. So don't approve something if it's not good, if it's not okay. Alright, now that's it, and now I'll see you for the next video. Thanks.